Well, look what Santa Claus brought me. Actually, he brought me 3 of these. So today's project, over the next couple days, I guess it'll take to complete it, I'm going to upgrade my batteries to lithium ion phosphate. So I guess I'll show you my current setup and as to why I'm going to go this route, how I'm going to go about it, and how I come to this conclusion and all that good stuff. Well, first of all, my current setup, I put these in maybe 6 years ago. These are GC45s. They give me a total of 510 amp hours. And they've done pretty good out of 6 years, but they're starting to swell up and get puffy. They're not going to last much longer. So I figured now would be the time to make the switch. Got the batteries on sale on Cyber Monday or something it was, so that helped me make the decision and go ahead and pull the trigger. I've been wanting to do this for a while. And I'm getting into more and more boondocking, and these will do okay if I need to just do one night. But if you wake up the next day and you got a cloudy, rainy day, not much sun, you know, you get hard pressed relying on solar to get those batteries back up again. So my setup here, I got these 510 amp hours of these 6-volt batteries. I've also on the roof I have 3 residential solar panels that I bought locally, so I didn't have the shipping, and they give me a total of 675 watts coming in. The other components I have is my trimetric, so that's telling me what's coming in and what's coming out. And another component I have is my Onan Energy Command 30 that, you know, has the auto start and all that stuff. It measures the voltage in the battery and will automatically start up and charge it back up. Something you can't see underneath the fridge is my a 60 amp converter. I'm trying to progressive dynamics, pretty common. It's got the little pendant down here that you can manually put it in boost mode. What else I got? Other component I have is a 60 amp solar charge controller, TriStar. So that's the components I have. So first thing I did, I made a short 5-minute video showing Battleborn the components that I have, just to make sure that all I got to do is buy batteries. I don't have to upgrade any of my components, and they reassured me that is true. All I need is batteries. There are some switches I have to change in here, some dip switches, and there's some settings up here on the TriStar that I'll have to, or the trimetric. Yep. There's some settings I'll have to change on it, pretty minor. So that's good to know. So that helped me make my decision. But they did make a comment about the fact that I made that video for them. Made it a lot easier for them because they could, you know, visually see my layout, what I had. Then we come to the process of, okay, where am I going to put what? Of course, with lithium-ion phosphate batteries, they don't like the cold. Unlike these batteries are exposed to the cold weather. So if it gets below about 32 degrees thereabouts, they got their onboard diagnostics. It's all underneath this cover because it's sealed up. But it's got all, they constantly control or monitor the temperature of the batteries. It's too hot, too cold, whatever. It can break the connection to protect itself. So I was thinking about that, and I thought, okay, how can I keep these warm, you know, below freezing? Because sometimes we'll be in a spot that's really cold. It's rare, but it does happen. And of course, some people just, you know, maybe they build a box. They do have like these heating pads that wrap around the battery or go underneath them, that you can do that if you had a nice insulated box. So I guess you could do that if you wanted to. This here is my engine starting battery. I moved it into this location because I filled that plumb up. But I'll pull all these out. Those will be gone. And my goal is to take 3 of these. I got to come up with a plan and a design, but I want to mount them back in this hole here. So it takes me back, I got 4 feet of space all the way back here to the back, and only need 3 feet. So because these batteries are sealed, there's no acid, no maintenance, I can mount them, slide them back in there, get them out of my hair, and not have to worry about it. I'll have to do a little rearranging with some wires and different things. That's my planning stage here tonight to get that done. So anyway, you kind of got the rough idea of what I want to accomplish. And of course, you know, another reason, a problem I've been having is with the boondocking, you know, is the time it takes to get these charged up. And that's going to be the great benefit with the Battleborns, is the recharge time is so much quicker. So if I just have a little bit of sun during the day, it shouldn't take long to get them back up to fully charged and get us through another night. So I'm looking forward to that. So I guess now it's time to figure me out a battery mounting bracket, something. I don't know what I'm coming up with, but that's my next project. Okay, well, it took me about an hour or so, but I came up with something, and I think this will work just fine. I think I'm out maybe $20 in materials, some all thread, these little angle brackets that you use on garage doors, and it's really strong and stout. Of course, I'll be cutting off this excess, but it's kind of like a rack, and I just slide it up in there. It's going to be kind of heavy because I'm looking about 90 pounds, but you can get an idea how I've done it. Because see, underneath everything will be nice and smooth, so it'll slide through there, and then I can use these holes here to anchor it down so it won't go anywhere, and I can always put some brackets about middle ways. So I think that'll work pretty good. I got me some new cables on orders, get them here Thursday. I got to get me make me up some double-aught cable. Gotta get that measured and do that tomorrow. So this should come along pretty smoothly, I think, if I don't have any hiccups. Alright, back to the RV now. Got my battery bank built, and I'm about to unhook all my wires. Of course, I did a separate little video here to remind myself where everything goes, and I've got most all the stuff labeled. There's one I don't have labeled, so I gotta track that down and label that. And I've made sure everything's unplugged. There's no current anywhere, so nothing can short out, sparks. Don't want none of that going on. Next day, and the battery bank is installed. I'm trying to get the light back in there where you can see. That's almost too bright. There we go. Dim it down a tick. So the battery bank goes all the way back in there. It's about 3 foot long. Pretty heavy, but it slid in there. Now I'm just doing a dry run. I'm gonna pull this back out because I gotta trim off some of these bolts. Some of them are a little bit long, but I'm just getting an idea of what it's gonna be like with my cabling, what kind of space I'm gonna have, and I'm still trying to figure out where I'm gonna put my bus bars, connections, and all that stuff, fuses, and I'm thinking I'm leaning to make a lot of my connections in here. It's a watered up mess right now. I'm going to try to clean this up, get these wires tucked in here a lot better. Might make my connections and fuses in here. I haven't decided that yet. I mean, this has been 6 years. There's a little corrosion on these. Not real bad after 6 years worth, but I need to, you know, see where the acid and the rust worked on that. But no more. Got rid of those goofy lead acid batteries. But I thought maybe I'll get these wires reworked around, seal up all these openings. Once I get those sealed up, then any connections I have in here should stay nice and dry and not have much corrosion issues, because things are getting tight in here. Time I get my water pump back in there and my solar charge controller, not a whole lot of space. So anyway, that's where I'm at the moment, just planning and seeing what I'm going to do next. Alright, getting ready to put this thing back in there for the third time. First 2 times I was doing trial runs, just getting an idea how I want to run my wires and put my bus bars and fuses and all that fun stuff. But now I've got my 2-aught cable hooked up here, 2 gauge between the batteries. Got me a whole roll here. A friend of mine owns a wholesale warehouse, so he just let me bring the whole roll. Let me borrow this really cool crimper, so I put a good crimp on those copper lugs. So I'm going to hopefully tuck that thing up in that hole one last time, get things anchored up, and then start figuring out the wiring situation, where what. I'm going to try to get everything inside this compartment. I don't know, it's going to be pretty tight. We'll see how it turns out. Alright, I guess it's time for a progress report. So, got the battery bank in there the way I want it. I got my main hot wire that's coming off the back post. And I figured out where I'm going to put my fuse location in the rear, the positive lugs up there, my bus bar, I guess you call that. And I'm working on my ground location. And right now I'm getting ready to take loose the DC shunt and move it over. And I got all those wires to get. I'm trying to get everything in the dry on my connections. It's going to be tight in here, but I think I can get it accomplished and put this mess all back together. So that's where I'm at, and just kind of a slow process, but that's where I'm at the moment. Alright, I wanted to stop and show you something. This tool is the bomb. It really does a sweet job. Put this in and give it a good squeeze. There it goes. That's a heck of a good crimp. She's not going anywhere. I looked this tool up too. It's like $200 for that thing. I'm glad he let me borrow it. So anyway, I'm making progress today. Just wanted to show that. Okay, just going to show a little snippet of some of the crazy stuff I've had to get into. Man, it's been a tight spot getting all these wires ran. Here's another one of my last runs. This is the solenoid disconnect for the house, and I need to get the positive wire right there over to the new battery bank. But originally I had it going down under the frame and all down in this box. I want to make a shorter path and go through under the floor and back around. But there's a little bitty hole back in there, if you can see. Maybe you can't. It's not going to pick it up, it's too dark. But anyway, I got a piece of cable. I got it bolted here so I can pull it through. I got it running around the bend. And you see I just got hooked to it right there. So I can pull it through, hopefully. I'll tug and push, and I'll eventually get my new cable through here. But you can see what a tight project that this has become. Okay, just a little bit of attention to detail. If you get into a project like this, you can see where I ran that new cable. I want to have to fish through there. Well, that's a metal hole, and it's kind of got a sharp edge. So I put some wire loom around the cable also. So as it wiggles, it'll always be protected. I don't have to worry about that cable eventually wearing through and causing a short. Of course, I got it fused, but still, you don't want no shorts. Something to consider. Alright, progress update. Working on grounds now. This here is the main cable that comes off the house battery bank. And you see I got this aluminum lug on there, which I did this 6 years ago, and it's held up, but it is getting some corrosion on it, because it mounts right here. That's the frame rail to the W24 chassis. So it's exposed to the moisture off the road when it's raining and stuff. So it is corroding some. So I'm going to get rid of this, cut this wire back, get some fresh copper, and go with a copper connection instead. And I'll update that one down there too, because that's the grounds going to my solar charge controller and my Xantrax inverter. But I want to point this out. Check out all these grounds here. So all these, half a dozen grounds goes into the main wire harness, controls who knows what. But can you imagine if you happen to get a loose wire here due to corrosion, lights are flickering and carrying on, how are you going to know where that ground is? You know, so it takes a while to learn your RV and find all this kind of stuff. Because this is on a, for 38J, if you got 38J, well now you know. But that's where it pays to get under your motorhome with a flashlight and go up and down the frame rail and inspect things, look at things. I remember one time I was just under there looking around, all the slides were closed and everything, and I noticed I had a water line that was being compressed by one of the slides. It's the water line from the engine. It carries the antifreeze from the engine back to the water heater to keep the water heater warm as you're driving down the road. And luckily I found that and rerouted it so it wasn't getting a worn spot in it, because over time it would have wore a hole in it, and I'm driving down the road, I'd be pumping all the water out of the engine, and who knows what could have, pumped the water out, overheat the engine, blow the engine up over something simple like that. So it's the little things that get you. So keep an on things, look around, inspect. So I'm going to get my little Dremel tool and clean these grounds up a little bit more. Get that in place, and then I'll be ready to do a test and make sure the inverter works, make sure the house lights come on, and then I'll slowly start piece by piece putting everything else back together. Well, I'm putting this back together sort of in stages. So I just put my fuse in, and my inverter is working. And you see, even these straight from Battle Barn, these batteries are sitting at 13.4 volts. Haven't even charged them yet. So that part is working, and you can see I got lights now. So all that's working. The power's going through the coach, running off the batteries because I'm not plugged up or anything. So my next stage is I got to work on getting the charge controller hooked up, the solar charge controller, and my DC shunt. I got to get it wired in for my trimetric so it can, and I got to make some changes too. I got dip switches to change on this, and some settings to change on the trimetric, so it'll work with these Battle Barn batteries, and I'll show you that here when I get to that point. Okay, it's time for a little update. It's been a couple days. It's taken longer than I thought it would. Of course, a lot of it is just the planning, the rearranging of all my wires, stopping to make all these cables, deciding exactly where I want to put the cables, how to run the cables, and all that fun stuff. But it's worked out pretty good, especially the fact I really don't have to change any components except for the battery itself. Of course, I upgraded my cabling. But when it comes to my solar charge controller, I didn't have to change it. All I have to do is go in here and change some dip switches. If you go to Battle Barn's website, put in, which one have I got here? I got the TriStar 60 amp, and they'll tell you exactly what switches to change. So this will work with their batteries. Same way with the trimetric. There's some settings on it I had to change, and I'm still tweaking on it a little bit. It does a whole lot of different stuff. So it has built-in alarms and all that. But you can see back here in the back, I got my fuse in place. And then, of course, I got my red bus bar for all my positives, all my negatives. There's my DC shunt that controls or measures the current coming and going out of the battery, so I know exactly what I got. And I've got everything repositioned in here nice and neat in a way that I got enough room. If I need to slide the battery bank out, I got to put me some brackets in here to lock it down, but I can get a hold of it and slide the whole thing back out without having to disrupt or get rid of anything else. What else have I got done? Well, of course, here's the engine starting battery. I decided to keep it in here, so everything, the house batteries and the engine starting batteries are out of the weather. They're in the basement area where it stays warm in the wintertime and protected from the elements. And you may be wondering why I've got hoses coming off the battery. Well, this is supposedly it's a maintenance-free battery, but it still has a vent on it. And because I've got it in the basement, I thought for safety's sake, if this thing was to short out, overcharge, or something other and produce fumes, I don't want that in the basement area, which would come up into the living area. So I've got these hoses put on here, and they run up and actually go right here, which is to the vent outside. When the door closes down this rubber strip, any fumes or anything is going to go outside. So that's what that's there for. Another little tip you might find handy. Whenever you get a new battery, always put the date and the warranty. I got the warranty wrote down over there. And put the receipt with it in a Ziploc bag, tape it to it. So when it goes to crap out on you, you can quickly look at it. You'll know if it's still under warranty or not. You have your receipt handy. You don't have to go digging through your digging through all your paperwork trying to find a receipt. In case that never works out usually. Let me see. All right, let's see here. Let me show you up here in my battery box. Got that cleaned up. I'm gonna paint it, primer it good, and I'll have some extra storage. I don't know what I'm gonna put there. I'm gonna make me a door here. I cleaned up my grounds really good. Got that looking good. I've sealed it. Got all my wires, everything fused. I put in new connections up here, ran new wires. Got everything tagged, so I know what it is. if I have to get in here and do any troubleshooting in the future, because there'll always be something. Then here's my trimetric. This here, I have to make a few changes to, but all in all, it's a pretty good project, and I'm gonna like it, I think. So I'm gonna do more testing with it here once I get everything put back together. So I'll hook up that ceramic heater, put a load on it, let it run for a few hours, pull it down, see how quick it charges back up. I'll be kind of curious how quick it does. Quickie video, everything's working, everything's put in place, nice and neat. You see I'm pulling about 80 amps. I've got my ceramic heater running, got plugged up on AC, got my battery box all empty now, trimetric's working, so woohoo! All is good in the hood, yay! Alright, quickie video, all my fuses, all my lugs in place. I got a ceramic heater hooked up. I'm not plugged up to 110 at the moment. Solar charger is working, trimetric's working, everything's back in place, everything's bolted up. All wires are run, new ground's fixed up, battery box is empty, ceramic heater's going, trimetric is working. I'm pulling, what are we pulling out? 966 watts. Looking good. So my curiosity is getting to me. It's been a few days since I installed these batteries, and you see I got the battery bank, what it says is down to 10%, and the voltage is 12.2. I have a chart over here, let's see how that corresponds. So that looks like it's kind of right on the money. They're saying at 12 volts is 9, I'm 12.2, 12.5, 14, so 10%, so it's pretty dang close. I'm just curious as to what's going to happen. I got a ceramic heater plugged up, pulling out 76 amps, which is about 800 watts or so. Down 10%, so I'm just going to wait to see what happens, at what point it actually disconnects. I'm assuming that's what happens. I'm assuming these batteries protect themselves when they get so low and just break the connection, but that I'm not for sure of. So stay tuned, we'll see what happens. Okay, update. We're down to 6%, which that's right at 12 volts. Ceramic heater still running. Went out 75 amps. Oh, down to 5%. I don't know. Can't believe it could go much further, but we'll see. We'll let you know when it stops. Well, here we are, down to 2. Heater's still going. And 11.6. We haven't disconnected yet. How low can we go? Okay, we're down to 1, but I just wanted to show you I got all the lights on. They're still fully bright. I mean, there's no dimming whatsoever. Ceramic heater still running. And we're at 1. Engine battery's 12.5. House battery's 11.3. Pulling 77 amps. Pretty impressive. Oh, there we went. Now we're at 0. So, yeah, we're still cooking. So, I'm looking at the stuff here, the paperwork. You know, it's got high-low voltage protection. And it says at 10 volts is 0, so maybe it'll keep humming until it gets down to 10. We will soon find out. Okay, now we're at 0. I'm hearing something. Something's going on. Okay. And my inverter is warning me. We're low voltage. It's squalling. We're down to 10 volts. But still pulling. Still says we got 11 volts. Let me turn off the heater and see what happens. Okay, so I turned off the heater, so now my inverter is not squalling at me. Okay, now let's see what its voltage says. Okay, now it's 11.7. You may not see it on the camera, but it's 11.7 on the inverter and 11.7 here. So they both are saying the same thing. And we're at 0. I guess I'll go right through the RV and kick on a few more lights and see what happens. I don't want my inverter to be squalling all that time. Don't want to damage it. Okay, now the inverter's fussing. All I have on is lights. No ceramic heater. Down to 10.7 volts. Still says 0, so it doesn't ever go below 0 no matter what the voltage is. 10.7, pulling 15 amps. Just keep watching it. We're getting close. It's dropping a little bit faster, I noticed. I'm kind of curious, because I got 3 batteries tied together, how that battery management operates when you got 3 tied together. Does, I'm assuming, maybe they all can't kick out at exactly the same time, so it just dropped to 10.3. Do they talk to one another and they all 3 kick out at once, or just one kicks out, then another, till eventually you have 0 volts? I just don't know. Questions. 10.2 volts. Oh, 10.1. The lights are still working. We're getting down now. Just kind of curious. Okay, inverter just got quiet. So that was kind of odd. Why did it get quiet? Everything is still working. Let's see what it's saying on the monitor. Oh, it's kicked out. Okay, so that inverter is kicked off. Okay. Well, I guess that makes sense. There's nothing in the inverters really powering. Everything's on 12 volts. It's not inverting anything to AC. There we go. 9.9. It still operates. The mystery continues. Okay, so my assumption is that's my converter. Wait a minute. Let me get my terminology right. No, that is. Oh, there we went. So yeah, we just whizzed down to like a little bit, just a hair below 10 volts, and it finally kicked off. So there we go. So now we know you can take it down to 10 volts and you will still have power. Okay, let's try another test. So what will happen now, I'll plug up to shore power and see what happens. If it's, I want to see how many amps this thing can take in, because the batteries are completely dead and off. Let's go plug up. Let's see what happens. Alright, back inside. Okay, you should hear a click shortly. I hope. Here we go. Alright. Alright, all lights are on. Got that happening. And let's see what kind of amps we're taking in. Alright, so now we're taking in 43 amps. I have a 60 amp converter. So it's taking in 43 amps right now. Let's kind of see how that does. Okay, check that out. So Battle-Born batteries are able to take in the full amount of my my converter, because it puts out 60 amps and it's taking in 58.8 amps, because I'm sure I got a little extra draw somewhere, because I went around and turned out all my lights. How about another test? What if we start the engine? What will change? Because then we'll have the power from the alternator of the engine also charging these batteries. Alright, try that. I'm in the middle of another project, you can see. I heard it started kind of sounded a little funny because the battery is so low. Wow, now look at there. 158 amps is going into those batteries. That's pretty sweet. That's awesome. Yeah, I don't know if you saw it, but it peaked there just for a second for it was at 160 amps going into those batteries. Yeah. It's all zero. I don't know. I wonder if I'm going to have to reset my trimetric. I might possibly have to. There we go. 164 amps going in. That's pretty good stuff. Okay, I just turned off the engine. And you can see the amps are dropping back down now. From 160 down to 58. Because that's just coming off the converter. Oh, and the converter that I'm using is a progressive 60 amp converter. Doing a good job. So at this point, I guess I could probably turn my inverter back on. Yep. Okay, it still works. I didn't kill it. That's good. And look at those amps going into it. I'm going to be curious to see how the solar works when I get this thing out of the building and get it a sunny day, because it's also a 60 amp charge controller, to see if it'll perform the same way. I imagine it's going to be pretty good. So imagine in a pinch, if you had a cloudy day and you wanted to charge up your Battle-Born batteries kind of quick, you know, you could start your generator. I'm assuming this will work. That'd be another good test. So if I start the generator right now, no, wait a minute, no, hang on, let me think of something. Okay, here's my next test. So I'm trying to imagine, say for instance, I'm boondocking, it's a nasty, rainy, cloudy day. I've killed my batteries over the last day or two, and I want to charge them up as quick as possible. So what would happen, because I'm out in the middle of nowhere, what would happen if I start the generator? Because the generator should power the converter, giving me 60 amps. Then also start the engine. So will that scenario work and still get me up there like 160 amps? So let's try that. Okay, just fired up the generator. And wait for it to switch over. Turn out some of these lights. We're only drawing 5 amps. Transfer switch should engage here shortly. There she goes. Okay. So off the generator. We now have 55 amps almost. Now let's start the engine. Remember, that starter sounds a little funky because my battery's getting so low. Even the engine start battery's getting low. Alright, so engine is running, generator is running. We got 145 amps. Well, let's sit here for a second, see if it gets any better. Okay, well, it looks like 145 is all we're going to do, but still that's smoking compared to, I wonder how long it would take to charge those batteries up. Next question is if it maintains that rate all the way up to full charge, 100%. That's the next question. Okay, here's the third test. Okay, this is the engine only. So I've turned off the generator, and this is solely giving me the amps off the alternator of the engine, what I'm getting. It's at 99 amps. Because I believe the alternator on this 8.1 Vortec is 145 amps. Of course, it's both charging the house batteries and the engine battery at the same time. Alright, now I'm going to plug up shore power again and see what we go up to. Alright, back on shore power. Let's see what we go when that engages. Any day now, let's click. Okay, shore power's back on. Amps are climbing, amps are climbing. There we go. 142 now. What was it before? I seen earlier that wasn't that up to 160, and that batteries were maybe at their lowest point. Okay, we've been here for a minute or so. That's where looks like we're staying steady at about 137. All right, so I'm gonna shut everything off. Okay, now seeing it's 2 o'clock in the morning, and so I've got my little pendant down here. I've got it in boost mode. So that's where we're getting our 60 amps. And I think it does that for 4 hours before it kicks out. So and then after 4 hours, I'm trying to remember, is it 13.6 volts is considered fully charged? I'll have to look at my notes from Battleborn and see. Okay, I need to give you a final update. I lost some footage on that last bit. But anyways, we've been running these batteries now for over a year. And they're just fabulous. And for us, 3 Battleborns, 300 amp hours is more than enough. I mean, we stay up late till 3, 4 in the morning running TVs and laptops. The batteries are fine. And, you know, come the next morning, the sun pops up, get a little sunshine, they charge back up. We got a cloudy day. You know, we'll start the engine, start the generator, slam a bunch of amps into it, and quickly charge the batteries back up. But I've quickly realized I can't be doing that to my alternator on my 8.1 Vortec, allowing it to throw out that many amps for any length of time at risk of damaging the alternator. So I'm about to install one of these devices right here. So you'll see that video out here shortly. But it makes for a great combination. Don't really plan on using it to run air conditioner or anything that way. But as far as power, it's all we need. And we saved a whole lot of weight too, like what, 300 pounds I think I was able to unload getting rid of those lead acid batteries. Thanks for watching. Have a great day.